Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 4 of the lesson on integration by parts, and in this video I'll be looking at how to deal with situations where you have to integrate by parts twice. So the first and most important thing is spotting that we're going to have to use integration by parts and that we're going to have to do it twice. Because fundamentally, with all the integration that you have to do in your A-level, the most important skill you need is deciding which strategy of integration you're going to use. So you need to be able to look at something like that and say straight away, I've got to integrate that by parts and I've got to do it twice. And the way that we know we've got to do it twice is that squared there on the 3x. So 3x squared means, right, we're going to have to integrate this by parts twice. Strap yourselves in for a long journey. Here we go. So we're going to call u 3x squared. And we're going to call dv dx sine 5x. That means that du dx is going to be 6x, and that v is going to be negative 1/5 cos 5x. Sine integrates to cos divided by 5. It's worth reminding every now and again, with these videos you should be pausing, trying to do it yourself, and then looking at my explanation for clarity to check that you're doing it right, rather than just passively letting it all wash over you. So here we go then, first stage of integration by parts. We're going to write out the formula that we're using, which is u dv dx equals uv minus the integral of v du dx, which means that the integral of 3x squared sine 5x equals uv, right, uv. So 3x squared times negative 1/5 cos 5x. So I'm going to write that as negative 3/5 x squared cos 5x minus the integral of v du by dx. So v is negative 1/5 cos 5x and du dx is 6x. So I'm going to write that inside the integral as negative 6/5 x cos 5x dx. Now, we're subtracting the integral of a negative. That means that we can change this to a plus. So we can write, and I'm going to do this before I do the second stage of integration by parts, we can write negative 3/5 x squared cos 5x plus the integral of 6/5 x cos 5x. And I've now got a second integral that I'm going to have to do by parts because I've still got the product of two different functions, 6/5 x and cos 5x. So, looking now at this one over here, I'm just going to say that u is 6/5 x and that dv by dx is cos 5x. That means that du by dx is 6/5 and that v is 1/5 sine 5x. And then I'm going to put that into my formula for integration by parts here. Now, students often say to me, Mr. Southern, do I have to carry on writing this bit every single time? Yes, you do, because otherwise you'll forget it's there. Right? So here's what we're going to do. We're going to write that first bit again, negative 3/5 x squared cos 5x. It's not going to change, but we don't want to forget about it. Now, plus, we're going to big square bracket this because this is now a separate integration by parts and we just want to take care with signs. So, uv, I've got 6/5 x multiplied by 1/5 sine 5x. So that is 6/25 x sine 5x minus the integral of v du by dx. So v du by dx, 6/5 multiplied by 1/5 sine 5x. So that is 6/25 sine 5x. With respect to x, close the big square bracket. And now you'll see, after the second stage of integration by parts, I've reduced this integral now to something that I can just integrate because it's a constant multiplied by sine 5x. I can deal with that with no further need for integration by parts. Okay, so here we go. Negative 3/5 x squared cos 5x plus 6 over 25 x sine 5x minus the integral of 6/25 sine 5x. Now, I've put a bracket here because we've just got to be careful. Sine is going to integrate to negative cos. So what I'm going to get is negative 6 over 125 cos 5x plus c. And I just need a final line where I show that subtracting the negative, that's going to go to positive. So my final result, negative 3/5 x squared cos 5x plus 6 over 25 x sine 5x plus 6 over 125 cos 5x plus c. Is that what you got? Coefficients correct? Remember the plus c? If you did, great. Something just to have a look at. Does our answer make sense? Well, actually, yes, it does, because look, we've got x squared, x to the 0, so we've got decreasing powers of x. That's good. We've also got an alternating pattern between cos and sine, which makes sense with this result as well. So there you go, integrating by parts twice, and the key thing was spotting that that was the case because the first function was x squared. So integrate by parts twice. Right, one more video on integration by parts after this. I'll see you then.